We've seen how by using a pulley system, you can reduce the force needed to lift something heavy, but the distance lifted is reduced, leaving the work done the same. Energy in equals energy out. Now let's look at a pulley system in more detail and think about forces instead of energy. A pulley system with one pulley is used to lift a mass, M. If we consider each bit of the system in isolation, we can work out the forces in the rope and on the ceiling. If the mass is being lifted at a constant speed, then the total force on it is 0, and so its weight, mg, must equal the tension T in the rope. T equals mg. If we assume that the rope is light and the pulley is light and frictionless, then the tension in the rope must be the same everywhere. It's equal to mg. And now we consider the pulley itself is being pulled down in two places by the rope, so the upwards force on it must be 2T, and the upwards force on it is being provided by the ceiling, so there's a downwards force on the ceiling. Using Newton's third law, every action has an equal and opposite reaction, so the force on the ceiling is 2T, which equals 2mg. Now let's consider a system with two pulleys. If we consider a force balance on pulley number 1, then we can see that the tension in the rope, T, must be equal to mg over 2. Now let's consider the forces acting on pulley 2. There's tension T acting down on it in 3 places. So that means the upwards force on it must be 3T provided by the ceiling. So the force on the ceiling is 3T. And that's equal to 3mg over 2. Now let's consider a system with 3 pulleys. If we balance forces on pulley number 1, we can see that the tension must be equal to mg divided by 3. Now, pulley number 2 is connected to pulley number 3 and is being pulled down by the rope twice. So pulley number 3 is being pulled down with a force of 1, 2, 3, 4 times T. So the upwards force on it must be 4T. So the downwards force on the ceiling is 4T, which is equal to 4mg divided by 3. Finally, a system of 4 pulleys. It gets more complicated to draw and harder to see. Consider pulley 1. It's got a rope pulling it up with tension twice. It's also supporting the lowest pulley. So the force that the lowest pulley is putting on it must be 2T. Now consider this lowest pulley. It's being held up by pulley number 1 with a force of 2T. It's also being held up by the rope twice. So the upwards force on it is 4T. The downwards force on it is mg. So 4T must equal mg. and T must equal mg divided by 4. The ceiling's holding up pulley number 4, which has the force of pulley number 3, plus the rope pulling it down. So the downwards force on pulley number 4 is 1, 2, 3, 4, 5T. So that means the upwards force provided by the ceiling is also 5T, and that means the downwards force on the ceiling is 5T, which equals 5 mg divided by 4. So, as we increase the number of pulleys, what can we tell? The tension in the rope goes down. So maybe we could replace the rope with a thinner or less strong one. The force on the ceiling also goes down, which means we need less support at the top.